Okay, welcome back, my dear. And in the last class, we have initiated that IP addresses concept, right? So there we have seen what is that IP addresses, and then what are the matters, what are the classes we are having, and then how that IP addresses are, written like that. Now we are going to see about the classes of that IP addresses. Okay, right. Let me move on to the class. Then we will explain all the things. Right. So as we know that IP address contains the 32-bit long, right? And this 32-bit informations will be notated in the two different formats, either in the decimal notations or in the binary notations. Okay. But in general, we are not going to use the binary notations because we are giving the decimal notations only. But as we know earlier that our machines are processing only the binary informations, automatically that decimal notations whatever we given to the system, that will be converted into the binary and then it will be started to process. Okay, right. So you see here, as I told you that in the second part they are telling in hex. Okay, the hex means the hexadecimal value, and it is they are mentioning that octet. Okay, already I told you that what is that octet. So that octet is the 8-bit informations. Okay, and as example they are giving here 137.207.192.003. Okay, so this is the IP addresses we are having. Okay, so what will happen here, that initial value, that means that first value of this IP address is 137. So it is in the range of you know the class B, because for class A we know that the range is starting from 0 to 126, and class B it is starting from 128 to 191. So this 137 falls under this category only. That's why we are telling this is the class B kind of IP addresses, and the corresponding hexadecimal value also given here. For 137 it is 89, and for 207 it is the CF, and then for 192 it is C0, and then for 03 it is the 03. Right. So we know that this is the hexadecimal notation and that one is that decimal notations. But in the last class also we have discussed that IP addresses is divided into two different part. One is the network part and then host part. And I told you that network part is used to identify that network category. Okay, and then the host part is identify that particular machine, client machine. Okay, so for an example I'm telling, if you're working in some laboratory, then there you can see multiple machines are working, right? And all those systems are connected with one server only. Okay, like that, if that particular organization having many blocks and then each and every block contains multiple system, means each and every block of that systems are considering as one group of networks. Okay, so each and every group of networks will be connected to that particular central server, and here any one block of system cannot access the another block of system, because that network ID is different from all other groups. Okay, that's why we are telling how they are identifying this network group means, uh, based on the classes, that network ID will be differ in each and every IP addresses. Okay, but whatever it is, that network ID is different, and then you know if any system having the same network ID, then that system can communicate with each other. It cannot communicate with other system which are not having the same network ID. Okay, right. So this is the simple structure of the IP addresses. So you see here it is the 32-bit long, and inside that 32-bit, what are the informations we are having, that we need to understand. Okay, so suppose if we are receiving some packet from some network system, then it will contain the IP header. Inside that IP header, it has that informations like version and the header length, and then what kind of services it has to do, and then what is the total length of the bits available, and then identification of the ports, and then flags, and then fragment offset, and then time to live, that means how long it can sustain in that network queue. Okay, for a particular time period only that IP address can hold the messages. After that it will discard or it will be lost. That's why they are telling the time to live. And then protocol, that means based on the services we are doing, based on that only some protocol will be chosen here. Okay, and then checksum values and source addresses and then destination addresses. So these are all the informations will be available in the each and every IP header. Then you see here we are having the five forms of IP addresses, that means the classes of IP addresses, as we have seen earlier in the previous classes. Here we are having class A, class B, class C, class D and class E. So we know that, right, what is the ranges of each and every classes. So here you see in the class A they are telling we can make 126 networks. Okay, and you see here the ranges are starting from 1.0.0.0 to 126.0.0.0, and class D it has that range is starting from 128 to 191. Okay, but basically they are mentioning like 127, but 127 uh, will not be used either in the class A or in the class B, because 127 is a loopback addresses which is used to verify the self-checking of network connections. Okay, and then class C, which contains 192 to 223. Okay, and they are telling that up to 254 nodes we can make, because you see here in the class C we are having the subnet mask value like 225.225 sorry 255.255.255.0. so in the last place we are having a 0, and the previous class itself I have told you that no class of networks can contain the fully 0 or fully 1. Okay, so it will be starting from 1 to 224 only, that's sorry 254 only. That's what they are telling. Class C can have up to 254 nodes. Okay, right, and then class D is multicast purposes, and then class E is reserved for the future use, that means it is under the research. Okay, that's why they are using these values. And this is a simple diagram which explains the five classes of the IP addresses. You see here in this diagram you can see one item like a network ID and then a host ID. For each and every classes that net ID will be increases and then host ID will be decreases. That means for class A we can use much more host ID. That means we can add multiple client machines with a single network. But if you're going for the class B, then that network ID will be increases and then host ID will be decreases. Okay, so that means here we can connect only few systems compared with the class A. Okay, but if you're going for the class C, it will take more net ID and then only few host ID. Okay, while comparing class A and class B, class C networks can create only few systems of network or host. Okay, that what they we can understand from this diagram. And then class D, class C is not for our users purposes. That's why there is no network ID and then host ID in these two different classes. So IP addresses here. So you see here one example they are given in that binary mode. So the first value is starting from 1 and then continuous 0. So I think it may be that 7 zeros. Okay, if you are converting this binary value into decimal, then we can get 128 as the answer for that binary. The same way for each and every binary value, that means the 8 bits of binaries, we can get a decimal dot notation like 128.7.15.1 as per the given value. Okay, so since this first value, that means the first 8 bit values are containing that 128 information, we can say that these IP addresses falls on the category of class B, because we know that the class B IP ranges are starting from 128 to 191. Okay, and since it is a class B IP addresses, we know that default subnet mask value, which is 255.255.0.0. So first two 16-bit values are used for network ID, and the last two 15 values are used for identify the host ID. That's why in this network ID they are mentioning 128.7. So this is the common term which is used for identifying the network ID, and then 15.1 is that host ID, that means the client machine's IP addresses, right? And here IP addresses assignment example. So you see here one example they are given. Here that a circle contains the pronet 10, that means it is like one of the server which IP addresses is 192.5.48.0. okay, that means it can communicate with other routers which having, that means other end communication devices which have the same network addresses, that means 192.5.48. okay, because we know that 192 falls on the category of class C. So class C subnet value is 255.255.255. So first 3 octet bit value it holds as network ID. That's why you see the link from this pronet to multi-homed host, or the gateway to pronet host. You can see all these IP addresses are starting from 192.5.48. okay, but the last bit value might be changed because the class C addresses from 0 to 254 IP addresses will be used for client machines group. okay, so for different client groups we are passing that information, and each and every client groups having some separate IP addresses which is accessible for the local communications. okay, so this is one kind of assignments, IP addresses assignments. So this is class A. Now we will see the brief explanation for each and every classes, and this is the class A IP addresses. As we know that earlier, class A contains only the ranges are starting from 0 to 126. okay, so it is by using this class A IP addresses we can create less than 128 networks. okay, but within these 128 networks, we can connect multiple host machines. That means you see the class A IP address ranges are starting from 0 to 126, and then subnet value for class A is 255.0.0.0. okay, that means that first 8-bit values are used for identifying the network ID, and then the rest 3 octet bit categories are used for creating that host ID. That means it will be starting from 0 and then ending with a 255, and we cannot use that 0 and then 255 as a IP address, right? So we can use 255.255.254 ranges. okay, that means for these three different octet bits values we can set the ranges from 0 to 254. So like that we can give 0 to 254 in 3 times. That means 255 into 255 into 255 combinations we can create the IP addresses. okay, that's why if you are looking for that kind of combinations, then we will have nearly that trillions or billions of IP addresses. okay, that means that much system we can connect with the class A network. That's what we are coming to say. And you see here the first one bit is used to determine the class to which an IP addresses belong to for class A addresses. okay, that means the first bit they are talking about. And the next one is for the next network addresses that I told you already, because the ranges are starting from 0 to 126. So up to 126 networks we can create by using this class A. But the rest of that 24 bits, because the first 8 bit only identifying for network. So among that 32 bit, apart from that 8 bit, we are having the 24 bit values still. So if you are giving that different IP ranges for this 24 bit values, then we can get that 16,777,216 of hosts. That means that much systems we can connect with class A networks. That's what they are mentioning. um, so this is about the class A, and class B, class C, and then class D we will discuss in the next classes, right? That's all about today's topic. And if you have any questions or any doubt, please feel free to contact me on the given email ID, and then my number also given here. So anytime you can call me. Thank you.